Hello, and welcome back to what I hope is a much more structured video than the last. Today, I am very excited to go over the design and implementation of a combat system for 3D games. At a very high level, the combat system is comprised of three modules. A combat module for handling the detection of combat engagements and combat lifetimes, an aura module for handling the application of auras from combat node engagements and the execution policies of their underlying effects, and finally an attributes module, predominantly as the source of detection for expired or defeated entities by checking health attribute modifications. The real heart of this system lies in the architecture of the auras and effects. Since effects and attribute modifications can come from a variety of sources, to account for the unknown, we route everything through auras. Auras are composed of a few parts. First, there's a series of enums dictating the specifics of how an aura is attached, executed, and what behavior is taken upon duplication. Second, we have three vectors with effect IDs determining what the aura does based on when it is attached, procced, and removed. Third, we have some lifetime and tracking information. And then effects are very simple structs. The overall design of an effect is to be an atomic unit of sorts. Upon effect execution, they are used to supply variable data to specific effectors. To give an example, I'd like you to imagine the following situation. Our player is completely surrounded by a horde of orcs and options are limited. Using their abilities to their advantage, the player self-immolates, combusting into flames and knocking back the horde, charring them. Now there's quite a lot going on under the hood, so let's break it down piece by piece. First, the player queues the self-immolate ability into the combat queue. During the combat update loop, the combat module ticks down the channel time for all queued abilities. In our case, this is an instant ability, so it's ready to go. Processing the ability consists of turning the ability data into a combat node that represents the location in 3D space that the ability is occupying, and it is then placed into a BVH of combat nodes. When the node is created, the aura IDs associated with the ability are placed onto the combat node. These will be used later to notify the aura module of what auras are to be applied based on a combat collision. After the ability queue has been processed, the combat node BVH is then collided against the entity BVH and valid collisions are returned. A collision is currently valid if no prior engagement lockout exists between the combat node and the entity. The current default lockout timer matches the default minimum ability lifespan, which is about a fifth of a second. The lockout time is required as combat abilities are persistent over some amount of frames, and I learned firsthand the consequences of the player being subject to combat without a lockout. The lifetime for combat nodes are not allowed to be 0. The inspiration for this design comes from the platformer genre of games and their coyote time. Briefly explained, coyote time is a grace period given to a player to perform a jump without actually being grounded. Translated to our combat system, something like the self-immolate should technically resolve instantly, however the player timing is not perfect and it would be very unfortunate for their single plan of survival to be missed because of a couple frames. Following the detection of combat collisions, two sets of notifications are sent out. The first set of notifications are about the general hit events that have occurred. There's a wide variety of modules that may be interested in that event, so it is performed separately from the notification of attached auras, which is our second set of notifications. It is during the second notification loop that should the performing entity have any combat modifiers like a multi-strike or chain attack, they are taken into account at this time. Multi-strike simply repeats the ability attachment multiple times, while chain will cause the ability to look for nearby targets it can jump to. Aside from handling the combat node lifetime, this is where the combat module ends its responsibilities in the combat system pipeline. The combat nodes are what I call an effect applicator. Effect applicators are a nexus between a high-level game module and the more shared data resources such as effects and attributes. Because an effect, or really an aura, can be applied from just about any module, a simple pipeline is laid out. We have effect applicator systems which feed into the aura module. The aura module will either process an effect or forward the attribute event to the attributes module, acting as a gatekeeper, in which the attribute module will perform the attribute modification. Here in the Aura module, we listen for two types of events, attachments and engagements. An attachment is produced by the specific handling loop an effect applicator system produces. As we just saw, this was processing the attached Aura IDs on the collided combat nodes. An engagement event is also something we just previously saw with the on-hit notifications being sent out from the combat module. I would like to note that an engagement event can be many different types, and hit is just one of them. Bringing this back to our self-immolate example, the player's ability combat node ended up colliding with our orcs here, and as such sent the Aura module a few messages about the attachment. While processing these messages, the attachment pipeline is invoked, and we first perform a duplication check. Should the Aura being attached to the entity not currently exist from the source ID, in our case the player's combat node, we attach a new Aura to the affected entity and process the persistent effects associated with this Aura. However, if we happen to already have this Aura attached to the entity, we would check the duplication behavior of the Aura and respond accordingly. For the self-immolate example, we will have two Aura attachments per orc. The first Aura will be for knockback, and upon attachment, the persistent effect of the Aura is to apply a force onto the entity that is resolved over time inside of the simulation engine. The second Aura will be the fire damage. On attachment, it will deal some amount of fire damage to the orc. However, we would also like the orcs to burn over time since they're charred, so we will set the proc type of this Aura to be a tick event, meaning it will be processed during the update loop instead of being triggered via event messaging. Now we can set an apply effect, meaning that when the effect is procced, in our case when the tick rate reaches 0, to also deal a small amount of fire damage to the orc as well. As mentioned before, effects are really just a container of specific data that is set up to be processed in a dedicated way. Depending on the effect type, a corresponding effector will be invoked upon execution of the Aura effects. For example, when the knockback effect is executed, the effect data will read the base value as the magnitude of the force. The effect is fed into the knockback effector and transformed into the knockback force. Similarly, when the fire damage effect is executed, the effect data will read the base value as the underlying damage to be applied, and the effect school will be used to add any bonus or mitigations. The biggest bonus to this design is a clear and predictable execution pipeline that allows emergence to arise based on Aura and effect combinations. Now currently, the spell effector is not up and running because I ran out of time and wanted to get this video out. However, let's just pretend that what we are currently looking at is the spell effect pipeline and not the melee combat pipeline. Here we perform our combat computation to get our final damage value. With this final damage value, we're going to create two messages. The first will be an engagement event signaling that there was a damaging event that took place between two entities. The second will be to the attribute module signaling a modification to the health attribute must take place on the affected entity to reduce its health by some damage value. Ideally, this pattern for notifications is to be preferred for all effectors. However, I currently only enforce the rule if an effector must communicate to another module. In the case of the knockback, I currently allow the module itself to directly update the knockback force. However, even this in the future, I plan on changing to this event-driven design. Moving on to the attributes module, we'll go ahead and process our messages in a similar fashion to the Aura module. We're going to have two main message types that we're looking for. First is general attribute modification. In our immolate example, when the health attribute modification message is sent, it is sent to the process attribute modification function. First, the attribute modification is checked for persistence. If the modification is temporary, tracking information is stored to allow for unwinding the attributes later. After this, we perform the actual attribute modification by getting the modified attribute type and forwarding our modified value and entity IDs to it. With the exception of stamina, all attribute modifiers are simply a lambda function that pulls the current attribute of the modified entity and then passes the new value to it. One note I want to mention is that the modified value is always added, so things like damage must be set to a negative value, or it will end up healing the damaged entity instead. Finally, because in our example we happen to be modifying health, we also make a special record of this modification for processing in the update loop. Each frame, when the attribute module does its update loop, it simply looks for only the modifications to health for the current frame. The idea is that if a health modification hasn't occurred, there's no way the entity has expired. So rather than checking each entity health value, we check only those that have recorded a change. If we indeed detect a modification that resulted in a health value being set below 0, a message is sent out to the various modules that a kill has occurred and cleanup is initiated. A nice byproduct of this design is that since the attribute module is common to all entities, it can be used as a control point for object deletion. For example, let's say we have a conjured companion that lasts 10 seconds. Rather than having cleanup code tied to the lifecycle of the companion, we can code all entities with a lifetime that upon expiration the health is set to 0. This will cause the system to automatically clean them up using the existing pipeline, avoiding a duplication of responsibilities. Before I close out, I want to add onto our example from before. Let's also imagine that alongside the self-immolate, the player also has an enraged aura attached on them. The aura listens for on-hit events, and whenever the player hits something, they gain a stacking buff of 10 strength for 5 seconds. Because we want the system to unwind the strength modifications upon expiration of the aura effect, we need to have a method for signaling to the attribute module the modification is temporary. When an attribute modification event is created, the effect base value contains the modification, and the underlying auxiliary value is the corresponding attribute. During build time, when the aura effect is created, we can make the attribute value negative to signal a temporary modification to the attribute. Then during runtime, when any attribute is modified, we check to determine if it's a temporary modification as seen before. Detection is very simple. All we have to do is check if the underlying value of the attribute type is less than 0. Then to store a temporary modification, we're going to take the modified entity ID and keep track of all sources that made a temporary modification. We insert the current temporary modification and the flat map will return it back to us to use, or should it already exist, say we have multiple enraged stacks already, we will get the prior modification state. Then using whatever is returned from the flat map, we simply record the new modification to the temporary attribute tracker. In order to unwind a temporary attribute, the system will look for a specific message that signals an aura detachment. Just to recall, we enforce a pipeline in such a way that the only way to modify an attribute is through the aura module. During detachment, all auras applied onto the entity by the source will be removed, and thus all temporary modifications from the aura will be undone as well. We grab the current modified value, negate it, and pass the negated value to the appropriate attribute modifier. In the future, a check might be done to make sure attributes don't go below 0 upon unwinding, but I'd rather let time tell us that we need that instead of just putting it in there. And with that, we have finally finished the overview of the combat system deployed in the game engine. One thing that was notably left out of this was the AI incorporation of the new design. I have chosen to go ahead and keep the very simple approach currently implemented for the time being, as it allows me to continue building and testing the game. I do have plans for sprucing up the AI in the future, but that will be done when I get back around to doing the navigation mesh once again. As you may have noticed, we lost our terrain and are now on a flat plane. This is primarily due to the speed at which it allows the AI to be built, but it also just didn't work. It is very finicky and edge cases have their own edge cases. It was a good attempt, but I'm afraid we'll have to go back to the drawing board and try something else. I do have my eyes set on the recast algorithm as it seems very promising, and that is a perfect segue into what we're going to do next and why. Following this video, we'll be stepping back into Manifest Framework and beginning the process of bringing the graphics up to date. I apologize if the recent videos have seemed more sporadic and less of a deep dive into a specific technology. It has passed a little over 8 years since I began this project, and I regrettably have yet to make an actual game with all of this technology. As I've alluded in prior videos, there is currently a game in the background being worked on, and I use it to introduce the new technology that has been added in the pursuit of completing it. Now, with the finalization of the combat aura and attribute modules, and the broader combat system as a whole, there really is not much left in terms of required technology to bring the game to fruition, aside from actually being able to display the game. So going forward, I am very excited to announce we will eventually be ditching our flat lighting, recolored cubes, and overall very bland world. I'm going to end the video here. I thank you all so very much for your time. I hope you have a great rest of your day, and I shall see you in the next one.